Well, continuing with the time value of money, we want to start using a timeline here so we can go forward, backwards, actually get to any place we want in time and get the value. And here we're going to look at the future value of a single sum. The question is, what is the future value of $200 invested 2 years from now if the interest rate is 10%? Well, here we're not given any compounding periods, and we've only got one number on the page, 10%, so we better use that. So what's going to be the future value of that $200 2 years from now at 10%? Well, here's the calculator solution. N is 2, our interest rate's 10. Notice we entered the interest rate as a whole value here, 10%. The present value is 200. The payment is 0, right? There's no other payments made into this account. And so that future value from the calculator, we get minus 242. Now we get the opposite sign of the present value. The idea being your calculator thinks if you put $200 in the bank today and earn interest, you can take out the proceeds in 2 years. Or if you look at it another way, if you borrowed $200 today at a 10% compound annual rate, you would have to repay $242 at time 2 years from today. And here's the mathematics of it. We're just growing that by 10% the first year and then growing all of that by 10% the second year. So we can certainly write it as 200 times 1.1 squared, and we can get the 242 there without having to use the calculator functions. Now let's go the other way in time and get the present value of a single sum to be received in the future. What's the present value of $200 to be received in 2 years if the interest rate is 10%? Well, that's just our discounting. We can certainly do it with the calculator. Notice now that our future value we've put in as minus 200, so we'll get the present value as 165.29. And again, payment 0. There's no interim payments, no flows into or out of this account. So if we put $165.29 in the account today and earn 10% compounded annually, there'd be $200 in the account after 2 years. And again, we can look at the mathematics of it and say now we're discounting. Instead of growing that $200 at 10%, we're going to divide by 1.1 twice and get the present value of 165.29. Now let's look at one where we've got some payments. When we talk about an ordinary annuity, that means an annuity that starts 1 period from now. First payment 1 period from now. For it to be an annuity, the payments have to be equally spaced periodically. And also they have to be equal amounts. So here, say we've got an account. We're going to deposit $200 into it a year from today. And then another $200 a year later, and another $200 a year after that. So here's one way we could approach that problem. That first $200, it grows at 10% for 2 years. The second $200 right there, that grows at 10%. And then the last $200 is paid in at time 3. So if we added up all those, we'd get $662. Now let's take a look at the calculator solution. We put the calculator in end mode, and that's telling the calculator that each of these deposits into the account comes at the end of the year. So we've got one deposit at the end of year 1, one at the end of year 2, and one at the end of year 3. So we've got n equals 3. We know they come at the end of the year. The interest rate's 10%. Our payment, we put in as minus 200. We could put it in as plus 200. Then our future value would be a negative. Doesn't really change much. Our present value is 0. There is 0 in the account today at time 0. And we compute the future value. Now, note that in end mode, this future value is at time 3. 3 periods from now. Now let's look at the present value of an annuity. And this really would answer a question like, how much would we need to put in the bank today, into an account today, in order to withdraw $200 3 times? $200 at the end of each of the 3 years, when the interest rate is 10%. So now we can just take the present value of each of those 3 payments, and that's what we've got right here. So we've got this payment, it comes 3 years from now, okay? And we want to take the value back to time 0. So we discount that. We divide by 1 plus the interest rate cubed. Here's the present value of this second payment here. Here's the time 0 or present value of this payment right here. We add them all up, and if we put $497.37 in the bank today, we'd be able to take out those 3 payments of $200, and that would just exhaust the account. The value in that account at time 3 is going to be $200, and we'll take that last amount out. So that's the present value of an ordinary annuity. And again, we're operating in end mode. We've got our payments at the end of each of the 3 periods, and those are our inputs. Now our payment minus 200. Future value is 0. Once we take this last $200 payment out of there, or receive that last $200 payment, the balance left in the account is 0. So that's our calculator solution to that. Now, what if we've got an annuity that doesn't start at period 1, or period 0 for that matter? Here we've got a 4-year annuity. It's $100 a year at the end of each year, beginning at the end of year 3, and our interest rate is 9%. Well, we could certainly do this the long way, right? We could say, well, this $100 comes at time 3. So if we want the present value of that, we just take 1.09 cubed. And then we could add that to this, 1.09 to the 4th, etc., and add them all up like that. However, we can do that with our calculator too. Now remember, in end mode, we're going to get the value here, 1 period before that first payment. So we put it in end mode. We put n equals 4 because we've got $400 annuity payments here. We've got our interest rate of 9. Our payment amount we put in is minus 100. Future value is 0. There's nothing additional at the end of this, just that last $100 payment. And get the present value of $323.97. But remember, that's a time 2 value in end mode. So there's our value at time 2 of all those payments. Step 2 is to take that time 2 value of $323.97 and discount that for 2 more periods to get that time 0 value, that present value. So we used our present value of an annuity tool to get the time 2 value of those 4 payments, and then discounted that back 2 periods at 9% to get the present value. And the interpretation of this would be, well, if there's an account that pays 9% compounded annually here, so we put $323.97 in the account today, we could take out these 4 payments of 100, 100, 100, and 100. So we'd say that's how much it would cost us to fund this particular 4-period annuity, 4-payment annuity. So let's look at another example using these concepts. We've got a bond that'll make coupon payments, interest payments of 70 euros at the end of each year for the next 6 years, and then pay its face value of 1,000 euros along with that last payment. So if the appropriate discount rate's 8%, what's the present value? what's going to be the value of this bond if we're discounting those promised cash flows at 8%. Well, let's take a look at our cash flows here. We've got 6 payments of 70 euros each, so there's our ordinary annuity. The difference is now that the bond's going to pay back its principal amount, its face value of 1,000 euros at maturity at the end of 6 years. So to set this up on the calculator, the only change now is we put in the future value of 1,000. And that's the future value at the end of 6 years. We're in end mode, each of those interest payments coming at the end of each year. And so the value of this bond, the present value of those promised cash flows, 953.77 euros. Now we're going to take a look at an annuity due. The terminology here just refers to an annuity where the first payment is made today at time 0. So we've got a 3-period annuity here, and we're going to calculate the future value. Well, on our calculator, we put in n equals 3, and we ask for the future value. We're still going to get the time 3 value. So now this is the value 1 period after the last payment is made, for example, into the account. So we can take the future value of each of these. We just compound at 10% for 3 periods for that first deposit today. The deposit of 200 a year from now earns interest for 2 years, and that third deposit earns interest for 1 year. So if we calculate the future value, we get 728.20. So here's our calculator solution. Now we're in begin mode for this. That's what shifts these payments back from what we had before. We had them at time 1, 2, and 3. Now we've got them at time 0, 1, and 2. So we go into begin mode if we want the value at time 3 of these deposits. We've got 3 payments. Present value is 0 today. We can compute the future value. Interest rate's 10, n equals 3. We're in begin mode, so that puts the payments right there. Now, we can do this other ways because we know the present value of that 200. Okay? And we could get the value out to here and then compound it for 1 more period. So we could solve it in end mode and then grow it at 10% again. But it's easy enough to do it in begin mode. I just recommend that you put your calculator back in end mode afterwards so you always know where it is and don't get confused about that. So let's look at the present value of an annuity due. Same 3 $200 payments, same interest rate, 10%. So the present value of that first payment, that's today's money, so it's 200. We take the present value of the other 2, add them all up, and that gives us the time 0 value of those payments, 547.11. On the calculator in begin mode, we can say n equals 3, 10%, here's our payments, future value 0, compute the present value, and get 547.11 that way as well. Now let's take a look at a perpetuity. We've had an annuity due, we've had an ordinary annuity. A perpetuity is just a perpetual annuity. It goes on forever. And non-redeemable preferred stock have an unlimited life. So here we're going to value a preferred stock that'll pay $4.50 a year forever. There's no maturity payment, there's no maturity. And the rate of return is 8%. What's the present value? Well, this seems a bit like a daunting task to take the present value of $4.50 every year forever. If it's truly forever, we're never going to get done. So what are we going to do? Okay. Well, we've got another way to approach this rather than an infinite series of those. Think of it this way. How much would you have to put in the bank at 8% to get $4.50 worth of interest a year? And so that's what we've written here, is we've got $4.50 equals 8% of some amount. And all we have to do is rearrange that to solve for that amount and get the present value of the perpetuity, just that constant payment forever, divided by the discount rate, gives us the present value of that infinite series. Think about it that way, well, as long as we just take the interest out every year, we can continue to take $4.50 out every year forever if we deposited $56.25 today. So that's actually the value of a preferred stock that pays an annual dividend of $4.50 when the required rate of return in the market on that security is 8%. Now, what about a deferred perpetuity? Well, we're going to use the same solution technique we did before, but now we're going to use the formula we just had to get the value one period before the first dividend payment, and then whatever value that is, we'll discount that back to the present. So we plug in, we've got the dividend, we've got that discount rate, so we get to $56.25. But that first payment comes 4 years from today. So that value we just calculated, that's a time 3 value. And so now we've got to discount that at 8% to get a time 0 value of $44.64. The interpretation being, if we put $44.64 in the account today and it earned 8% for 3 years, then we'd have $56.25. And then we would earn these interest payments of $4.50 every year forever.